All right, the last example we're going to work through here or the next example rather, we're going to work through here is, again, from page 629. And we're going to see if we can work number 20. So number 20 says this. We're given vector v and vector w. Vector v in number 20 is I plus j, and vector w is I minus bj. Excuse me, it's I plus bj. All right? So the coefficient, or excuse me, the component of the j vector is not known. So that's what we want to work with. And we want to find b such that vector v and vector w are orthogonal. So we want to find the value of b, which will cause these vectors to be orthogonal. Depending upon the value for b, they may or may not be. We want to find the value of b that causes that to occur. And so, let's see what we have here. Well, what is it required for the vectors to be orthogonal? What's required for two vectors to be orthogonal? Yes, that means they meet at right angles, but what does that mean computationally? The rule we had from our previous work is vectors are orthogonal if and only if their dot product is equal to 0. Vectors are orthogonal if and only if their dot product is equal to 0. And so that's going to allow us to set up an equation and back solve to find the value for b. So establish the condition to be met, which is the dot product must equal 0, and then solve to find what value causes that to occur. So we require v dot w to equal 0, which is to say, that's the same thing as requiring well, that's the dot product, 1 times 1, 1 times b, which is to say we're requiring 1 plus b to equal 0. Well, that seems pretty straightforward. B is equal to -1. So the value that required for b to make these two vectors orthogonal is -1.